based off the graphs. All we're looking for is it growth or decay? So all we're looking for in these answers down below is growth or decay. Growth or decay. Don't write that down. I'm just kind of tell you what you need to be writing in those blanks. Now, again, I'll do the first one with you just so that you understand what the table is asking. It says, when you have a positive exponent and a base value that's greater than 1. So let's go up here and tell me which one, 1, 2, 3, or 4, has a positive exponent but also a base of greater than 1. Do you see how 4 has a negative exponent? I'm looking for positive.
1.
Number 1. You see how number 1 has a positive exponent and a base bigger than 1. What's going on? Am I growing or decaying? Growing. So see if you can fill out the chart that way. So growth. And I can even put number 1 just so that you know that that's where we got that information from. And see if you can now apply that to the other 3 ones. Okay, the next one is you're looking for a negative exponent and when the value of b is greater than 1. We're just making these rules so that you can kind of have something to reference when you're doing these kinds of problems. So look for the one with a negative exponent and the base value greater than 1. Are you growing or decaying based off the graph? I'm not hearing math talk. We'll be changing groups by the end of the week. Way too much going on. Lately, you guys have been talking way too much. When you're done and when you're done only, you can go ahead and take a look up. I hear your music, then you need to turn it off or you need to lower it. Do you have questions on these? Yes.
Why is it growth for 3 if 3 has a negative exponent?
So let's talk about that. So a lot of people actually had this question in first hour too. Yes, the negative exponent flips it, right? Which means I have 3 over 2, which means I'm growing. Because 3 is bigger than 2. Yep. Which really is 1.5. Okay, so check your answers and see how you did. Do you have any questions on any of that chart? Again, that's just for you to reference if you're trying to figure out kind of general rules. That is it. Okay, I want you to take a minute with your group and try A, B, C, and D. Determine if the following is growth or decay. That's what you had to do on your homework. Okay, try to take a minute. I'll give you 1 minute to tell me if it's growth or decay. When you're done and when you're done only, take a look and see how you did. Hold on. Come on, pen. It's like making it be negative. Okay, there we go. Okay, do you have questions on these ones and why they are the way they are? Okay, before you determine if it's growth or decay, flip the fraction. Or use the chart to help you out, but I would recommend not memorizing the chart and actually just understanding what's going on. I flip the fraction, I get 6 over 5, and that's why it's growth, because 6 is bigger than 5. If 6 is bigger than 5, that's how we know. It's growth, it's bigger than 1. Do you have questions? Okay, I'm going to ask you a question that's very important that you're going to need to know. And you did it on your homework last night, but I think sometimes we get a little stuck on it. In green, what do these pieces tell me? Stretch or compress, that's a good question. That's a good answer, but what else? Your y-intercept. These pieces are your y-intercept. So again, you don't have to write this down. I'm kind of going off the side, but if you want to, your y-intercept would be 0, 2 here. It would be 0, 5 here. It would be 0, 10 here. And it would be 0, 0.7 here. Okay, so for those that got stuck on your homework with that question, that's your initial amount. Think when you're initially starting, like when I'm here and I'm starting, I'm not walking yet, I'm starting at 0. So that's your initial amount, because that A value in front technically means your initial amount, which we'll get more into in the next couple of days when we do word problems. But that number out in front is telling you where you start, and that's why it's the y-intercept, yes.
So the y-intercept is the a value?
Yes.
Okay.
Yep. The y-intercept will be your a value, and here's why. When I plug in 0 here, I get 5. 1/6 to the 0 power. Anything to the 0 power is what? 1. And that's why 5 times 1 gets me 5. Because when you plug in 0 for x, you're finding your y-intercept. All right, flip the page. So right away, before we start, I want you to change this to a 1. There's a typo on the notes. When the graph, this a value, so this piece right here, this a value out in front, which we just kind of talked about with the y-intercept. The a value in front, if it's bigger than 1, the absolute value of it, what's going on? Stretch or compress? Stretch, yeah, I'm going to stretch. We're getting back to transformations. You've done transformations in almost every single unit in Math 3. Did I press start? Okay, I did. All right, now when I'm between 0 and 1, which means I'm like a fraction with the numerator smaller than the denominator is, what am I going to do? I'm going to compress. Okay, so this is what we're going to talk about today. We already did this yesterday, so this part really isn't going to be new. It's going to be new in a second here is this a value. So we really haven't graphed things with an a value yet. So when I'm looking here, I don't have a negative exponent. What's my base? It's 1/3. So does that tell me growth or decay? Decay. There you go. Which means I'm always decreasing. D, always decreasing.
I'm confused.
On what part?
The growth and decay.
So growth and decay. What's that?
I said I know we went over it, but
Yeah.
it's-
So
don't you have to flip it?
only flip it when there's what in the exponent?
Oh,
A negative. So if it was negative, it would be growth.
So do you go by like the top number?
Yeah, so you see how the top number is smaller than the bottom one?
Yeah.
So that's less than 1.
Okay.
If this was a 4, it would be bigger than 1.
So it would be growth.
Okay, that's a good question. So that 1/3, that's going to be our base, but we also have this piece in green. That's why I like using highlighters, just to kind of show me here. What's my transformation? Yes, I'm stretching by 2. My whole entire graph is stretching by 2. When I stretch by 2, do I change my x values or my y values? Your y. Because when you're putting in a number, you're going to be multiplying by 2. And that's going to change your y values. You're putting the same x value, but you're getting something out that's bigger. It's getting twice the size. It's like if I took you and I stretched you up, you're going to get skinnier and narrower. If I compressed you and I took your height and I shrunk you down, you're going to get wider, right? That's why I always wish I was taller, because you'd be taller. That's my opinion. Okay, so let's talk about these though. We kind of practiced this yesterday. Let's practice it again. We really want you to do this without a calculator, so please put your calculators away. We want to see that you can do this without one. Here we go. So I have 2 times 1/3 to the -4th. That's what this means. And if I kind of have these whiteboards here, if you're someone that doesn't really want to write all over your notes for side work, if that interests you, you're more than welcome to grab a whiteboard and write the work on the side if you want. Okay?
Where's some marker?
I just made that really intense, I know. Okay, so here's the question. What is 3 to the 4th power? What's 3 times 3 times 3 times 3?
81.
81. Now with a negative in the exponent, what happens to it?
1 over 81.
It is 1 over 81 right now. It's going to become just 81. Okay, so I'm just gonna rewrite that out just so that you can see that. Right now I have 2 times 81. Here's why again. 3 to the 4th power, if I cover up this negative, 3 to the 4th power is 81. This negative then takes it from the bottom and brings it to the top. That's what the negative exponent does. It brings it from the bottom and it takes it to the top in this situation. Okay, so again, I know that, you know, it's not really hard to multiply 2 times 81 if you go off to the side. What is 2 times 81? 162? Is that what you said? 62. Okay, I'll do one more with you, then I'm going to challenge you to do the rest. So again, off to the side. You can go off to the side here. And I'm going to do 2 to the 1/3 base, and I have a -3 exponent. Now again, in my head, you have to apply exponents first because rules of, please excuse my dear Aunt Sally tells us we have to do exponents first. 3 cubed is what? What's 3 times 3 times 3? What do you say? 27. So right now, I have 1 over 27, but what happens with the negative? It flips it, it brings it up. So technically I have 2 times 27. What is 2 times 27? 3 to the 3rd is 27. And it's on the bottom currently. The negative, like we talked about, brings it back up. Okay, what is 2 times 27?
54.
Okay. It's not 54. Yes, it is. Yeah. All right, do the rest. Now that we've done 4 and 3, you should be able to apply it here. The only thing is when you're working with fractions, actually let me do one part with you with the fractions. I want to do this one with you right here. So this 3rd. I have the same situation. I have 2 to the 1/3, but now to the 3rd. It's the same situation as this. We just did it in our heads, so don't do too much work. We just did it, but it's not a negative, so it remains in the bottom. So that means it's going to be 2 times 1 over 27. See that? Wait, did I do that wrong? No, I did it right. Here. Okay? But now when I multiply, I only multiply to the numerator, and I get 2 over 27. So I want to do one of them with you. Now I'll finish the table. Because 1/3 is 1 times 2. Well, what is... Well, when you put in a 1, I'm going to keep doing them with you. When convenient. All right, I'm going to walk you through these for some of you that are getting confused. Don't worry. Okay, but you have to make sure you're paying attention and trying it and doing the work with me. Okay, a lot of you are like, I'm confused, I don't understand what's going on, but you're not participating in class, and that bothers me. Okay, so when you don't actually, you're not active participant, and you ask me, I'm not going to respond. That's how it's going to go from this point forward, because I'm really tired of reteaching people that don't even do anything in class. Okay, so let's talk about this next one. I have 2 times 1/3 all to the -2. I'm going to walk you through this, how my brain works. I just apply the 2 to the bottom first. What is 3 squared?
3 squared,
9. So right now in my brain I have 1/9, just this piece. But with the negative, what happens? It flips it. So now I have 2 times 9, which is 18. That's how I'm getting 18 there.
Oh, I have a question. I'm kind of jumping ahead, but for like the 1, 2, 3, and 4,
Mm-hmm.
is it gonna be 2 over?
Almost all, at all of them, yeah.
Not 1.
You're right. All right, so this next one. When I plug in the -1, I get 3, and 3 times 2 is 6. Do you have a question on that part?
0.
Yeah, 0 is 2 because anything to the 0 power is 1. So I would have 2 times 1, which is 2. Anything to the 0 power is 1, always and forever. A million to the 0 power is 1, yes.
Okay, so for the transformation,
Mhm.
the 0.
Mhm.
All right, so is the 0 always gonna be the number of the transformation?
It's going to be the A value, which we kind of talked about on the first page. So remember when we came up here, we said, oh, that y-intercept, what is it? See how the 2 is here and that became our y-intercept? That's kind of what we just talked about. Yeah, so that's a good correlation. When I plug in 1, here's where people were getting confused. You're not going to use these values because it's different. You're multiplying the numerators together. But you're still going to use those cubes or the squared. In this situation, we're to the first power. So I have 2 times 1/3 to the first power. Well, then it's just 1/3. So I would just have 2 over 3. Because you just multiply the numerators. So many times we see people put like 2 over 6. You only multiply the numerators together when you're multiplying fractions. If it had a denominator, then we'd multiply those together too. But okay, here I would have 2 times 1/3 to the squared. 1/3 squared. Well, 1/3 squared is what? 1 over 9. Very good. Okay, so then we have times 2 is just 2/9.
Wait, so what are you multiplying?
So right here, this piece in yellow, I would get 2 times 1 over 9. And then when you multiply them, you get 2/9.
Guys, if you are using a calculator, you are only hurting yourself because you're going to have to do this on the test without a calculator. Okay, I see people using their phones. I don't know what you're doing, but if you're not paying attention to how to do this, you're not going to know how to do it when it comes to the test.
And again, this is something like, at least this piece, obviously you would not have to graph on your own on the SAT because they don't ask for like you to graph something. But this is something they'll ask you. They say like which form is equivalent. You'll have to be able to manipulate like we're doing right now with that negative exponent and move it to the top, to the bottom. You have to be really good at rules of exponents. It's okay, we're going to keep doing it though. You're getting better than you were yesterday already. So, SAT in April. What did you guys get for 4? Yep, 2 over 81. Okay, we're going to do this together. Actually, no, you plot the points and then we'll do the rest together. You plot the points and then we'll do the rest together. Plot the points. I'm giving you 1 minute and 1 minute only, so plot those points. Obviously, you can't plot 162 unless you change your scale. But as long as you get the general shape of it, we're happy.
I'm just gonna plot them at random points.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
But it's gonna be.
You should have got something that looks like this. Questions on that? I'm just graphing it. Okay, what is the domain of all exponential functions? All real numbers. Okay, the range. I cannot express how many times I saw this last period. A lot of people put negative infinity to 0. That's not true. Negative infinity is down here. I'm starting at 0 and I'm going on forever. I'm starting at 0 and I'm going on forever. So I'm 0 to infinity. Do I include 0? No.
When would you?
Not in any of these. Yes.
How are you starting at 0?
Good question. So this is going to slowly approach your asymptote. Let me explain the asymptote first. What's the asymptote? What is this? It's 0, which means I will never touch 0. The graph will never actually cross at 0. It might get really close, like extremely close, but it will never actually touch 0. So you're starting at like 0.999 or 0.0001. Like you're starting way lower than 0, but you're going to represent that as 0, but I'm not including it. Okay, so I'm starting at 0 here, and I go up forever to infinity. Wherever your horizontal asymptote is where your domain, your range should be.
Kind of think about it as you were little, probably if you have siblings or you with your friend, you're like, I'm not touching you, I'm not touching you. Get as close as you can, right? To them without touching them, to annoy them. Yeah? Same thing. Your function is getting so close to 0, but not ever touch it. Play that I'm not touching you game.
Okay, so end behavior. I recommend writing them out like this before you even answer the question. Okay, your limit statements look like this. As x approaches the left side of the graph is what this is saying. So if you're trying to really understand mathematically what this is saying in English, as x is approaching the negative infinity off to the left side, the negative numbers, the function is going where? It's going up. It's going to positive infinity. So let me explain that one more time. Here I am. I'm x, and I'm walking towards negative infinity, but my function is shooting up to positive. That's what limit statements are. You're describing where those arrows are going at the ends. That's why it's called end behavior. Now, as I'm walking towards positive, the right side of the graph, the function is going where?
Down.
To what number? 0. Do you see? If you put negative infinity, I'll explain to you why that is. If you're trying to do negative infinity, I'm going to show you what that really means. That means like you're going like this. You're going down. You're going to keep going, but I'm not. I'm going towards 0. Okay, so that's only going to happen if you have like a cubic. That's when you would have that, but we don't. Okay, next one. Y-intercept. What is it? 0, 2. Remember, that's the A value. It's the number out in front. Am I always increasing or always decreasing here? Decreasing. Left to right. Read it like a book. Read it like a book. If I go left to right, I start at the leftmost point, and I go to the right, I'm going down. And I'm always going down. When you say forever and always, it's going to be your interval, all real numbers. So all of your x's at all times from left to right are decreasing, always. If you start your leftmost arrow and you start going to the right, you're going to end up decreasing. That's what that really means. Okay, now let's talk about transformations, which again, we've done a lot of transformations in our Math 3 career here. So based on your knowledge of transformations on several functions, what do you think the negative a value, remember when I had a parabola and I had a negative a value, what happened? It reflected over what axis? The x-axis. So this a value right here, when you put a negative there, it reflects over the x-axis. Now, when we had that negative up on the exponent, we did this yesterday, it flipped over the y. Okay, and that makes sense. That's why we're decreasing. It flipped over the y. Here, we're reflecting over the x. So like when we had quadratics, it was up. Now I'm going to be going down. Same thing in this situation. All right, so let's talk about that. If you notice, it's going to be a very similar problem. But now we have 2's here. We're not going to talk about growth and decay yet. I mean, technically, it looks like it's going to grow, but this negative out in front is going to do something to it. So the only time your growth and decay are going to be affected is if you have a negative in front. Okay, so kind of a little trick for you before we actually get into it. What am I doing originally? Growing or decaying? Growing. And if I throw a negative, I flipped it. So I'm growing. Here I am. Wait, hold on. I'm growing. If I flipped it, what am I going to do now? I'm going to decay. Okay, so it's kind of like a preview of what's about to come. Again, I am a growing exponential function. Is this a growing exponential function? Do I look like an exponent? Okay, and I flip you over. Now you're going to be decreasing. We're going to get into that though. Okay, so transformations though. I'm reflecting. That's what we talked about. Over the x. And what does this 2 tell me I'm doing? I'm stretching. Very good. I like how you said vertical stretch. I'm stretching by 2, which really means I'm just multiplying by 2 to all the y values, or negative 2. Okay, I'm going to do a couple with you, and then I'll have you do the remainder. So I'm going to do this first one with you. Again, if you like whiteboards because you don't like to put all the scratch work on there, that's fine. So off to the side, I'm going to go ahead, and I'm going to put this in. I have negative 2. And we're working with 2's, which is not very difficult. 2's are pretty easy to work with. So, in my head, what's 2 to the 4th power? 81. No. To the 4th. Not 3, 2. 3 to the 4th power is 81. 16. Very good. 2 times 2 is 4. 4 times 2 is 8. 8 times 2. Hold on. I can't do that without moving my pinky. Okay, 8 times 2 is 16. So I have the 16, but what happens with the negative? Where's it go? It goes to where? The bottom. So I have negative 2 to the 1 over 16. It's okay. You can do it all on paper. You don't have to do it in your head. I'll explain it one more time. They're easier when I have the little numbers here. That's easy. But I have 2 to the 4th. If I just cover that up. 2 to the 4th is 16. This negative tells me I'm going to put it in the bottom. That's all we did there. So now I have negative 2 times our 1/16, which really is negative 2 over 16. Would you reduce that? Can you? Yes. What can I reduce it to? There you go. Cool. Chill, man. Or you could just tell me and not talk about it behind my back. That'd be great. Okay, so I didn't put an R for over. Okay. Oh. All right, let me try a different one with you. Let me do the other side. Let's do this side. And then you can come in for me here. So here we go. I'm going to do 2 to the, negative 2. Negative 2 with a base of 2, and I have to the 4th power. Didn't we just figure out what 2 to the 4th power is? What is it? Good, it is 16. So negative 2 times 16. Sometimes it's easier to work with non-negative exponents, right? Okay, I know this might be like challenging your brain, but you know how to multiply anything by 2. Go to the side and do it. Negative 32. Very good. Now you guys can take it inside. Like, go ahead and work your way in. So I did one on this side. I did one on that side. Try to use that as a guide to get you there. If you need side paper, if you want a whiteboard, you can have one to do these problems. The only thing. When I plug in 0, I get 1, right? Oh, so it's negative 2. And then this one's negative 2. And I plug this in, I get 2 times negative 2. There you go. So just look at, pretend the negative's not there for a second. Let's choose 2. So you're thinking of 3. Yeah. You're doing it reverse. So 2 times 2 is 4. 4 times 2 is 8. Good. And is 8 going to be on the top or the bottom? Bottom. You get negative 2 times 1.
Negative 2 times
The negative 2 only multiplies the top. So it's nice. Divided by. Because you're scared of fractions. Okay, I know that a lot of you are like doing a fantastic job and you're writing all this down. We really didn't give you a lot of room for that, so we apologize. But like I said, there is whiteboards and scratch paper here. If you would like to go off to the side and do it, that's fine. Hopefully we have more room on the test. That might be something to bring up at the meeting.
Yeah.
Okay. All right. So I'm going to go ahead and put these answers down, and I want you to check them. And if you got it wrong, I really want you to tell me, and I will explain it, because I'm not someone that's going to move on until you understand it. So please let me know if you're getting any of these wrong, and I will explain it. Were there any of these X values that you got wrong that you would like me to go over? Okay, very common. This one, these two are the most common wrong. These two in the middle. When I plug in -1, all that's doing is telling me my 2 is currently in the numerator, it now goes in the denominator. So I have 1/2 here. So -2 times a 1/2 is just -1. Because the 2's cancel off. It's okay. And then this one, 0. Okay, when I plug in 0, I get 2 to the 0 power, which is just 1. Anything to the 0 power is 1, and 1 times -2 is -2. Okay? All right, now what I want you to do is just take it from here, because we have been doing this part for a couple days now. See if you can take the graph and apply it to these problems. So graph it out for yourself and do everything you see on my board right now. I want you to complete.
I would suggest you graph it first before you try to figure out those characteristics we're asking for.
So then you would actually have to like make your so you would put 6 is the y value. 6 equals find your base. So you would have the x for your base. Sorry, you have a base of x and you have 1 up there. Please let us know if you're needing help. We'd love to help you.
Are we starting at 0 going up? Or are we starting at starting here, we're just going up there? Negative makes 0. We're starting way down here. We're going to keep going down, right? So we're actually starting at -2 and then we're just starting at 0.
When you're done and done only, start checking your answers. I'll explain the range in a second. I feel like a lot of people get the range wrong on this one. Four to the 4th power is going to be 256. Because right, 4 times 4 is 16.
Yeah, Matt, you that noise.
That's not me. Hannah, don't look at me. That's not me. It is Russell.
Whoever it is, just stop. Okay, question. Yeah, so let me explain the end behavior and the range, because they're the 2 most common incorrect answers on the exam. Okay? So the range and the end behavior are the 2 most incorrect answers on our exam that we've noticed in the past 3 years that this has been going on, the Math 3. So the range is always bottom to top, and here's what I'm going to do for you. When you're talking about range, you're going bottom to top. Well, that arrow's pointing down to negative, and the other one's pointing up to positive. I'm in with my highlighter. I'm starting here. Oop, that's supposed to be a highlighter. I'm starting here. That's where the arrow's going. And I'm stopping right here. So I am from negative infinity and I stop at 0. That's what the range is. Okay, so be careful with your range. Okay, now, when we're talking about our end behavior, so watch my highlighters. This is, I'm weird with highlighters. I love highlighters. There's 4 of them now. Okay, as x is going to negative infinity, that's blue. Watch, here I am, I'm x, I'm going to negative infinity. Where is the function going in green? The function is approaching 0, and that's why it's 0. Here, as x is going to positive, here I am, I'm walking towards positive. In purple, I am going down to negative. That's how I'm getting those end behaviors, if you were wondering. Yes?
So it's the same with the range.
The range is your y coordinates.
So for the function, where the function's going, I didn't even notice the range.
Yeah, yeah.
I didn't even notice you were recording this as well.
Yeah, always. All right, okay. Let's look at this next one, then we're going to be done. It's the last one we're doing. I lied. You're doing it for your homework. Do it, and I'll give you your homework.
Wait, what if I have a question?
I'm so confused.
We'll come and help you.
I was like trying to figure it out, but like, it was so confused. It's like, I don't know. It's just like that.
Oh no, I think it is.
Yeah, 1 over 2 would be nice. Are you near them? Yeah. What happens?
Yeah, I know. So I just have to do it to the side.
Okay, so I know that you're working with big numbers. I get it. Just go off to the side and work it out. You're challenging your brain. You're giving it food right now. Yeah, the food is making the math is making it stronger. I will give you your homework once you're done, and you raise your hand.
Is it decay? Wait, so 1/2 is being compressed.
Stop making it not until I win. We're gonna give you
Stop hurting yourself. Jose, stop hurting yourself.
We will not be giving you this difficult of one on the exam. But if you do it,
Oh, no.
this one's gonna be This is a challenge. Can you help me?
This does not make any sense.
The homework is so fast and so easy. The first pages.
Those are the challenging ones. Try to at least do these. That's how you like to.
One over 128, doing
So we do our one to like 1 to 8.
no,
If you can at least get. I threw my pen somewhere. Where is it? There.
no, it goes 1 over 2 and 0. And it goes 1 over 8, then it goes 1 over 32, then it goes 1 over 28.
Yeah, I thought it'd be 1 to 8.
1 over what?
How do you go from 32 to 28?
Careful. I'm gonna go over that one.